everyone, Mrs. DeMeyers here. Welcome to lesson 4.2. Today we are going to analyze claims and evidence regarding our orange-bellied parrot population decrease. So if you're ready, let's go ahead, grab your Moon Jelly booklet. I got mine right here, and let's get started. So first things first, learning attention. All students will be able to use their annotated evidence cards, so that's these guys that you did yesterday with Mr. Vandergrift, to annotate the island ecosystem food web, noting the population changes and the strength of the evidence. Our success criteria: I can carefully consider all available evidence before making an argument about a phenomenon, specifically the decline of the orange-bellied parrot. Let's go ahead and turn over to page 110 and get started. So the first thing you're going to do is read over the first paragraph 2 times. Then take a moment and read over the unit question, chapter question, and key concepts. Now, with the key concepts, I want you to read 3 of them out loud and act them out with hand motions in some way. So get creative, get a little dramatic, and make sure you share this with your fabulous audience. So I'll take a moment and show you what I'm talking about. So if you look at the third key concept, it says, if the number of births and deaths in a given time are equal, then the population size will be stable. So I would say, if the number of births and deaths in a given time are equal, then the population will be stable. So that would be my hand motion. So go ahead, take a moment, pause the video, and read page 110, and make sure you act out 3 of the key concepts, okay? Pause the video now. Welcome back. I know you had a great time acting out your key concepts. So let's go ahead and go next over to our warm-up. So take a moment and look at page 112. Read over this warm-up, and then make sure you tell your fabulous audience. And if you need a couple of sentence starters, they're right down there at the bottom of the left-hand side of the screen. So go ahead, pause the video, and complete the warm-up. Now that you've completed the warm-up, let's take a look at our answers. So first, the question the warm-up asks is, how might an increase to the size of the sparrow population affect the orange-bellied parrot population? Well, first of all, let's take a look at the sparrows. Here they are in the food web. So we're saying, if this population increased, then the buttongrass population could decrease because simply put, there's more sparrows. More sparrows require more energy storage molecules from their consumer population, the buttongrass right here, which means there would be less energy storage molecules available for the orange-bellied parrots. So this population could go down. So to sum it up, we could say an increase in the size of the sparrow population could mean a decrease in the buttongrass population because the sparrows would eat more buttongrass. That could lead to fewer energy storage molecules available to the orange-bellied parrots, which could make the parrots reproduce less, and that could reduce the size of the orange-bellied parrot population. So go ahead, take a moment. If you didn't have quite that written in, write something along those lines in, and then if you want also to put these arrows in, I like visual pictures, go ahead and do that on your warm-up now. Let's take a moment and remember what our goal is. Our goal for this whole chapter is to answer the question, what was the main cause of the decrease in the size of the orange-bellied parrot population? So remember, we're saying that the population decreased because either the births decreased or the deaths increased. And those are the 2 claims that we're going to be looking at. One of the things that makes science interesting is when you can really see what's going on in the world. Now, obviously, we can't all travel to Tasmania and take a look at some orange-bellied parrots. So I found the next best thing. I found a video, and take a look at this, that just shows some of the beauty of the birds, and it gives a little bit more depth to them other than just on a 2-dimensional piece of paper or from your book. So go ahead, take a moment and look at this video.
The orange-bellied parrot's one of our most endangered birds in the entire country, so there's only about 50 of them left in the wild, and they live down in Tasmania where they breed, and then they make this incredible journey hundreds of kilometres back across the Bass Strait to come and spend the winter in the mainland. So there's this incredible little battling bird which is up against a lot of challenges, in their everyday life, and over the years they've just struggled to deal with it.
I just love the colors on the birds. Look at that. They're so pretty and vibrant. That green chest with that orange belly. So that's the bird that we're looking at right now. So let's take a moment and turn to page 113. What we're going to do on this is we're going to analyze the food web, okay? So you're going to go ahead and read over the page 113, and you're going to annotate your food web. And what that means is by each of the populations here, you're going to indicate whether they increased, decreased, or remained stable. And here's another piece, is that if your evidence card says that maybe you don't have evidence or you don't have enough evidence, you can put a question mark by it. You can say no evidence. Just whatever you need to do to indicate basically what is going on. You can see it all on the food web. So you want to indicate population increase, decrease, or stable. You want to indicate if there's data. And I would even question, put some annotations on there that indicate if it's good evidence, bad evidence, or maybe the locations, just some of my ideas. So go ahead, you do annotate your food web, pause the video, and go ahead and do that. And then we'll come back together and I'll show you how I annotated my food web, okay? So pause the video now. Okay, so you're back, and I know that you have annotated your food web. You're not just skipping ahead of the video, but you actually paused it. If for some reason you didn't pause the video and annotate your food web, go ahead and take care of that now. So one of the things about me is I love celebrating small victories, and I also love SpongeBob. So really quick, victory screech. Here we go. Get ready. And yay! Congratulations, you annotated your food web. Celebrating the small victories, SpongeBob style. So let's go ahead and take a look at these evidence cards and see how we annotated our food web. First up, I went ahead and chose evidence card H to start with, and that is Pixie's Parasol mushrooms. Now, right on this evidence card here, it says, we do not have evidence. So we don't know what's going on with the Pixie Parasol mushrooms. There's no data, there's no data collection locations. So on my food web, I'm just going to put some question marks and write no data because I don't have any data. All right, simple as that. So let's go ahead and go to the next card. Again, this is evidence card G. This is the long-nosed podoros. And once again, scientists do not have evidence. We've got no evidence. We've got a little unhappy face here. I wrote a question mark on my map. My graph says there's no data available. So on my food web, I'm going to indicate no data with some question marks right by my long-nosed podoros. Interesting fact about the long-nosed podoros. When I was looking at this, I thought this was a mouse. And come to find out, it's not a mouse. It's actually a marsupial. And if you don't believe me, take a look at this video really quick, and you'll see it hops like a kangaroo, which it doesn't, you can't even tell that from the picture. But so go ahead, take a look at this video, and then we'll come back and go sort through some more evidence. Isn't that cool? Did you have any idea, looking at the picture, that it was a marsupial and related to the kangaroo family? I had no idea. So again, it's amazing what you can discover on YouTube. All right, let's go to our next evidence card. That would be the Tasmanian Devil. But see, when I think of Tasmanian devils, this is what I think about. And obviously, we are not talking about this guy. We're talking about the Tasmanian devils on Tasmania. Now, once again, I love my videos because these are animals that we don't see. It's not like we can't easily go in our backyard and see a long-nosed podoros or a Tasmanian devil or an orange-bellied parrot. So I like to see what the animals look like in real life and what they do. And I want to show you this video of a Tasmanian devil. Kind of cool, kind of scary. You'll see why they get their name.
It roams the night, bellowing blood-curdling screams in search of dead and dying prey. And when it tears into flesh, it's with some of the most bone-crushing jaws on Earth. This fiendish fighter may look cute, but its name says it all. The Tasmanian Devil.
So yeah, he may look cute, but you would not want that for your pet. So let's look at the Tasmanian Devil evidence card. So our scientists concluded that the population decreased over 50 years. And if you take a look, there are 10 locations here where they collected evidence, and it's really spread out. So this is a really, really, really good piece of evidence. So on my food web, I went ahead and put a big arrow down, showed me that it's decreased. Personally, again, I like to use arrows more than words because sometimes I feel like pictures, they say a picture is worth 1,000 words. For me, I like my pictures. So I put my arrow. You could just write decrease on yours. You can put an arrow. I noted that it was 10 locations where they collected the data. And I also put a star on this picture because that tells me this is a really strong piece of evidence. Okay. Moving on to our next evidence card, it would be evidence card E, the sparrowhawks. And once again, the scientists collected data from 8 different locations. It's spread out all over the island. and they concluded that the population decreased over 50 years. So I've got my little arrow here, and you can see on the graph how it's decreasing down. And so on my food web, I went ahead and annotated, put a big arrow down. I indicated that scientists took it from 8 different locations. And once again, I went ahead and starred this piece of evidence. Not as many locations as the Tasmanian Devil. Tasmanian Devil had 10, but still a good amount of data collection locations. Moving on to our next card, let's take a look at the sparrows. This is evidence card D. And scientists concluded that the number of sparrow births has actually increased over 50 years. But here's something interesting. What they said is that they counted the number of eggs in sparrow nests at 5 sites in the middle of the islands. So they're concluding the sparrow births increased because of the number of eggs. Now, once again, they have 5 locations, not too bad, but the data is only in the middle of the island. And I would question personally, just because they saw eggs, how do we know that these were live births? Did the baby survive? We don't know. We don't have that information. So on my food web, I went ahead and just indicated more births, question mark, because we know there's eggs, but we don't know if there's eggs survived. And I also indicated that it was only in the middle locations of the island and that there was 5 data collection points. So we've got the increase here, made my arrow a little bit smaller because this is an okay piece of evidence. It's not great, it's not bad, but it's not as good as our sparrowed hawks or our Tasmanian devils. So looking at evidence card C, the red foxes, scientists took data from 4 different collection locations. Again, these are only in the middle of the island like the sparrows, and they concluded that the population increased over 50 years. So again, we don't have as many data collection sites as with the Tasmanian devils, and they're not spread out as far. So this is, it's an okay piece of evidence. So I've got my arrow going up here. I'm indicating, there's an increased question mark, that they only collected from the middle locations and there's only 4 of them. Okay, so moving on to our next piece, our feral cats that were introduced. They are definitely non-native to the population, as Mr. Vandergriff referenced, and they were introduced here. And the scientists collected the data from 1 location in the middle of the island. Not very strong data. The scientists did indicate or conclude that the population increased over 50 years. But once again, we only have 1 location collection site and only in the middle of the island. So it's not really a great piece of evidence. So I went ahead and indicated here a little tiny arrow up, and I said 1 location, but it's weak evidence. Our next card is our button grass. And just like with the feral cats, the scientists only collected data in the middle of the island and only from 1 location. And from this, they concluded that the population increased over 50 years. So here we've got our graph. But once again, this is just in 1 location. So when on my food web, I went ahead and noted that there was an increase, but it was only 1 location and it was weak evidence. Okay, so that is basically how I annotated my food web. So now that we've done that, give yourself a round of applause. Woo-hoo. Take a break. Wipe the sweat off your forehead. Go ahead and flip over to page 114. And we are going to sort your claims by evidence. So what I want you to do is pause this video and read it over, and then I'm going to come back and explain it more, okay? So go ahead, pause the video now. What we are going to do is you're going to sort your evidence cards, so these guys here, by either claim 1 or claim 2. Now, what I did to sort my evidence cards is I went ahead and just created this little table on the slides. And you could do the same thing with 2 pieces of paper. You could take 1 piece of paper and divide it in half. You could just write down on your evidence cards whether you think they support claim 1 or claim 2. You could use the back of them. If you don't have an evidence cards and you were just taking note on paper, you could just denote it on a piece of paper, which claims they support it. So then let's take a moment and go ahead and start sorting our evidence cards. So let's go ahead and take a look at our first evidence card. That's the Pixie parasol mushrooms. Now, scientists don't have any evidence about this population size. So guess what? There's nothing we can do with it. It's got absolutely no purpose to our investigation, to our claim. So you know what we're going to do with it? We are just going to throw it out. Our next evidence card G, the long-nosed poteros. Once again, no evidence. We don't know if the population increased. We don't know if it decreased. We don't know if it stayed stable. So we don't have a piece of evidence this piece of evidence doesn't support anything. It doesn't support any of our claims. So we're going to do the same thing with it. We're going to throw it out just like we threw out the mushrooms. Okay, our next evidence card. Let's look at evidence card F, the Tasmanian devils. So again, the scientists concluded that the population decreased over 50 years, and they took the data from 10 locations. So remember, on our food web, we had a big star on this one because we said this was a really good piece of evidence. Well, we are going to put this under the claim number 2, that deaths increased. So we're going to say that a decrease in the Tasmanian devil population caused the deaths to increase in the orange-bellied parrot population. Let's take a look at our food web and answer the question why or how that happened. So let's see here. If our Tasmanian devil population decreases, okay, that means that there could be an increase in the long-nosed potorous population. Because remember, this is the arrows show which way the energy storage molecules are transferring. So Tasmanian devils are eating the potoroses. So if there's less Tasmanian devils here, there could be more potoroses. There could be a population increase in the long-nosed potorous population. Well, more energy storage molecules here, or an increase in the population here, could cause an increase in the red fox population, which is supported by one of our pieces of evidence. Now, if there's more red foxes, those red foxes are going to need energy storage molecules. Where are they going to get them from? They could very well get them from the orange-bellied parrot population. So this supports the claim that a decrease in the Tasmanian devils could cause an increase in our orange-bellied parrot in the deaths of our orange-bellied parrots. Let's look at our next piece of evidence, evidence card E. So now we're here with the sparrowhawks, we're saying that the population decreased over 50 years. And again, this evidence was taken in 8 locations. So this is a really good piece of evidence. Let's see where we put it on our sorting page. So the sparrowhawks support the claim, number 1, that births decreased, and that was the cause of the decrease in the size of the orange-bellied parrot population. Let's take a look at our food web and see how this could be the case. So if our sparrowhawks decrease, okay, there could be an increase in sparrows. Because remember, the energy storage molecules are transferring this way. Less collared sparrowhawks means that there's less eating going on of the sparrows, which means they could increase. Now, an increase in here could cause a decrease in our button grass. Now, according to our evidence, it does say that there was an increase in button grass, but remember, this is weak evidence because there's only one location. So maybe in the middle of the island, there was an increase in button grass, but maybe in other places there was a decrease. And if the button grass did decrease, there would be less energy storage molecules available for the orange-bellied parrots, which means if they have less energy storage molecules, they have less ability to reproduce. So once again, a decrease in the sparrowhawks means that there could be an increase in the sparrow birth population. This could cause a decrease in the button grass, though we're not sure on that. And if the button grass decreased, there would be less energy storage molecules available for the orange-bellied parrots to reproduce. Okay. Let's take a moment and look at evidence card D and figure out how we would sort that. So for our evidence card D for our sparrows, scientists concluded that the sparrow births increased over 50 years, but again, they only took their evidence in the middle of the island. This is one of those pieces of evidence, again, we're kind of scratching our head because they counted the number of eggs, they weren't looking at live births per se, there's only 5 locations, and they're only in one location of the island, only in the middle. So is it good evidence? Is it bad evidence? It's kind of like, it's kind of sitting in the middle right there. So let's see where we put this on our sorting card. Okay, we went ahead and put this under claim 1, that an increase in the sparrow population would cause a decrease in the births of the orange-bellied parrot population. Let's take a look at our food web and see why. So once again, if there's an increase in the sparrows, they could eat the grass, which is their consumer population. If this population decreased, there would be less energy storage molecules available for our orange-bellied parrots to reproduce. So therefore, there would be less births. Our next piece of evidence is the red foxes. Once again, this piece of evidence is just kind of okay. It's only in the middle of the island. There's only collection locations from 4 locations in the middle of the island. And so for this red foxes, we went ahead and stuck it under the claim number 2, that the deaths increase. So an increase in red foxes would cause an increase in the deaths of the orange-bellied parrot population. Let's go to that food web and find out why. So if we have an increase in red foxes, they are going to be looking for more energy storage molecules, which means they're going to go after one of their consumer populations, which is our orange-bellied parrots, which means the deaths in the orange-bellied parrot population could increase. Now let's look at our pharaoh cats. Again, there's only one location here in the middle of the island, so guess what? Yep, we're going to toss it out. We're not even going to use it. Because remember, we're looking for samples that represent as much of the whole as possible. And the samples that represent as much of the whole as possible, they provide stronger evidence. That's part of our evidence criterion. So when we're developing our arguments, we need to use strong evidence. And a sample or an evidence card that only shows samples from one location in one part of the island is not a strong piece of evidence at all. So let's look at our button grass. It's the same case. There's only one location. It's only in the middle of the island. So we're going to do the same thing with this one. Yep, we're going to throw it out. Now I'm going to give you another piece of evidence, and you're going to decide what to do with this piece of evidence. You can use it, or you could not use it. And you can sort it however you best see fit. So this is evidence card I, or orange-bellied parrot. Let's take a look at it together. It says orange-bellied parrots have a layer of fat on their bodies. This is where they store most of their energy storage molecules. Okay. Over 50 years, scientists analyzed the fat of the parrots that were collected at 3 locations near the west coast of the island. Scientists concluded that the fat on their bodies has decreased over 50 years. So scientists had 3 locations, the west part of the island, and they concluded that the fat on the bodies of the orange-bellied parrot has decreased over 50 years. Go ahead, make a decision, and think about where you're going to put that piece of evidence. Now, to sum it up nicely, this is what we decided that we were going to do. To support claim 1, that the births decreased and that caused a decrease in the size of the orange-bellied parrot population, we are using evidence card E and evidence card C. For claim number 2, that deaths increased and caused a decrease in the size of the orange-bellied parrot population, we are using evidence card F and evidence card D. And remember, evidence card I, it's totally up to you. So go ahead and take a look at page 114. That's where we've been. And I want you to go ahead and fill out this bottom section on reflecting the claims. So you need to take a moment and mark in the box and make a decision for your argument that we're going to work on tomorrow, which claim you're going to support. So are you going to support claim 1, that the population decreased because births decreased, or are you going to support claim 2? Or are you going to make that your argument, that the population decreased because deaths increased, okay? So check one of these boxes, and then remember to check which evidence card supports your answer. Now, if you're not sure, you don't remember, just rewind the video. You can see I've got the graphic up that has all of them there. And then remember this evidence card I, that's your decision what you do with it, okay? So guess what? We are done with lesson 4.2. Woohoo! Do your happy dance. Yeah, I saw yesterday Mr. Vandergriff. He got to see my video first, and he found my graphic here, and yeah. So this is what that happy dance normally would look like, but we need to get him a Bitmoji, don't we? Anyways, I'm off topic. I will see you guys tomorrow for lesson 4.3. Have a great rest of your day. Bye.